Hi everyone, in this video we're going to have a look at chapter 6.5. So we're looking at the relationship, or the relation y squared equals x. Something a little bit different, because we're used to y equals something x squared or x cubed. This time we've got y squared. Okay, so essentially all we're doing is the opposite of a quadratic. Okay, so usually quadratic for x looks like that. Y equals x squared. Now, it's basically the same thing except it's on the side. So just looking at a couple of points. What happens at x equals 1? So here's 1. Okay, our corresponding y value, y squared equals 1. So we actually get the square root of it, so plus or minus square root of 1, which is just plus and minus 1. So here's our first point, okay, at 1, positive 1. But as you can see, if we go down, we also get another point there. So 1, negative 1. So get 2 points for the 1 x point. Now I could do the same for 2, 3, etc. And I'm going to get 2 points. If you notice, it's not a function because it fails the vertical line test. Okay, I'm going to get 2 points wherever I find the vertical line. So a couple of key points. We've got a domain of all real numbers, or all positive real numbers, because we start from 0 and we go all the way up to and keep going on to infinity. So our domain is going to be all positive real numbers, including or union 0. Okay, because r plus doesn't include 0. We want to include that point because it does touch that, so it's r plus in union or including 0. The range, it's going to go all numbers, so our range is just r. Okay, range is all real numbers. Turning point, sometimes we call that a vertex. Okay, for y equals y squared equals x, we're going to have a turning point at 0, 0. We've got an axis of symmetry. Usually it's vertical, okay, like our x squared graph, axis of symmetry. This time our axis of symmetry is actually horizontal. Okay, so all these numbers are reflected by each other. So you can say axis of symmetry is horizontal line y equals 0. Okay, axis of symmetry, y equals 0. And for our relation test, it's going to be 1 to many. Okay, 1 to many. So it is a relation, it's not a function. Now, okay, y squared equals negative x. It's going to be pretty much the same thing, except now we go this way. Okay, a reflection in the y-axis. Okay, and you're going to get a point here at minus 1, positive 1, here at minus 1, negative 1. Okay, turning point at 0, 0, and our range, or our domain, sorry, is going to be all negative real numbers, including the set 0 again, and the range is going to be all real numbers. Okay, so that's y squared equals x. Okay, so just having a look at transformations. Now I'm going to have the general equation okay, y take k squared a x take h. So a vertex, or our turning point, has coordinates at hk due to the horizontal and vertical translations h and k. So vertical this time is going to be our h, and k is going to be our horizontal is h, vertical is k, just as usual. Axes of symmetry has an equation y equals k, so that's when we had a y equals 0 for the past example. If we have a greater than 0, the graph opens to the right. A less than 0 opens to the left. Okay, a greater than 0 is going to be like that, less than 0 like that. There's always one x-intercept. Okay, doesn't matter what value we have for k, h, a, etc. We're always going to have one x-intercept. And that's found by y equals 0 as usual. There may be 2, 1 or no y-intercepts. Okay, none, 2 or 1. And that's again, we found that by x equals 0, just sub that in. And solving for the quadratic for y.